All right, let's talk about ERV design. I'm going to show you a system here and talk about some of the levers that you can pull as an engineer to better design and assess your ERV in your system. And we're talking about energy recovery, heat recovery, ventilators. So in this project, I have 6 fan coil units, and they are served by an ERV, dedicated outside air supply system. So let's look at the configuration for this system. In here, I've got my fan coil units. They have return air coming back from the zone, cooling and heating components, and I'm supplying 52, 90 degree air and cooling and then heating. And then this is the ventilation air coming in. So right now, that's set up as a DOAS unit. I've got my ventilation air coming in, being conditioned to 72 cooling, 68 heating. So basically just fully conditioning the outside air before it's being directed to the zones. I do not have an ERV component on. So I'm going to add one and look at what that does for my cooling and heating coils here, what the contribution is, and what kind of gains I see. So of course I want some spaces for outside air, confirming the same here. And let's go ahead and look at the loads for these cooling and heating coils at my essentially my DOAS unit, my ERV central system. So when I go to my summary, I'm going to go to my system here. If I go to my zone, I'll be able to see the fan coil unit data. I can see my outside air coming in is already tempered. But when I look at my ERV, I'll see I have outside air, there's no ERV yet, and then the coil is bringing the outside air down to my 72 degrees that I set to temper it. I'm looking at about 2 tons of cooling to accomplish that. So I'm actually going to go split screen here and show you some of the different things we can do to manipulate this. So let's duplicate this, and I want to keep my results open, and I'll pull them off to the side. So here's my ERV system. We'll just look at cooling. So here's my cooling coil data right here. I've got 1.97 tons to accomplish what I'm asking it to do. Now over here, I'll actually look at my design here. So the first thing I'm going to do is actually turn on my ERV component. I'm going to turn it on, and the effectiveness is set to 75, and you can see it dropped down to 1.53 tons on that coil. So what's going on? Now that I have this ERV applied at this unit, it's taking the exhaust air present in my system and running it back through the energy recovery process to get me this tempered state of air after the ERV process. So now, when I have this off, you'll see that I have basically 0 exhaust air being used for this process. And then when I have it on, I have 264 CFM of exhaust air available for this process. So that's the first thing that we're going to manipulate to try and improve this. And basically, if I go to my air balancing here and I look at this system, I'll see that, okay, for my ventilation, I need 900 CFM. I can see the real raw breakdown here. There's 868 outside air required as a system. There's 264 CFM of exhaust air present in this system based on a few of the different space types that require exhaust. So looking at those, I've got a restroom area here that requires about 150 CFM of exhaust, and I've got a kitchen here that requires about 120. So if I leave this as is, I'm getting a really, decent but ineffective ERV system because I have so little air that I'm actually returning back to regain some of that energy. So let's improve that. Instead of sticking with the minimum required exhaust for this kitchen, if I were to up this to 500 CFM of exhaust, then I'll immediately see, boom, now I'm bringing in 650, and the tonnage on this coil went all the way down to 0.86. So remember, without making this correction, we were at 1.53 tons on this coil. When I add the ERV and up my exhaust for some of these spaces, now there's more to bring through, and I'm at 0.86 tons on that coil. So it's not just enough to throw an ERV there and not do anything on the air side, not balance any of those CFMs, supply, exhaust, all that, to have a really efficient system. When you're using an ERV, make sure you look at where your exhaust is coming from and consider increasing your exhaust to see more of those gains on your coils here. So that's the big thing that you want to look at when designing your ERV. And of course here in HVAKR, doing this kind of analysis is a really quick way to start to play around with that and see what the gains are. So let's say I also increase the exhaust in my restrooms, bring that up to say 300. Now we're looking at 800, and this went down even further. Let's look at the configuration again, and let's say our ERV is only 60% effective. Well, now we're looking at 0.88. Let's say it's 80% effective. Now we're looking at 0.50. And again, if you remember how we started, when I turn this off, I'm looking at almost 2 tons. So this is a small system, just a few zones that this is being applied to. But imagine this at scale with a large project, and you can really see the difference you can make by paying close attention to how you are configuring your ERV and balancing your exhaust. So I hope that was a kind of fun snippet, a quick tutorial on ERVs for you guys. Enjoy.